Good morning, Pathophys. It is Wednesday, April 15th. I haven't looked yet. You had an assignment due last night. I know a few of you were concerned because you turned it in after midnight. I'm not worried about that. Late is only something Google Classroom has. And if I put a time in there for due date and you turn it in after, it's going to mark it as late. But as long as I get it in a decent amount of time, when I say decent amount of time, it's within a day or two afterwards. I realize there are other things that are happening. Things are changing a day at a time, and it's important that you take care of your families and your responsibilities at home first. School is one of those responsibilities. And just to kind of give you a breakdown of what I'm looking at for the remainder of the year, we would have at this point 4 weeks left, about 4 weeks and a few days of school, with some obviously interruptions mixed in there, which aren't going to be a factor anymore. But what you need to understand is that over the next 4 weeks, I'm going to give you the material that I typically would give you, which includes 3 more projects and a few more chapters. And it's going to be in the format that you've seen over the last month or so. So if you have any questions or concerns, let me know. If there's something else that you want to see, if there's a topic that you want me to cover as a group or individually, I'm open to suggestions at this point. I have a number of different pathways that I've used in the 12 years that I've taught this class. I probably have, even though I only assign typically 6, 7, 8 projects during the course of the class, I probably have 20 different projects available to me, different topics that I've used over the years. So if there's something that you'd rather me do, rather that we can work on, just send me an email, and I definitely would entertain that as an option. Anyways, everything's been great so far. You guys, we were actually surveyed yesterday as teachers, and we were asked what classes we're doing best as far as getting work turned in, percentage of students completing tasks. You guys, by far, are my best class, and I really appreciate that. So make sure you keep that up. We just have a month left at this point. So regardless if we get back for those last 2 weeks or not, I'm still going to be delivering curriculum, whether it's face-to-face, that's the hopeful part of it, or just using the same technology and format that we have for the last month. So regardless, I'm going to give you the information, I'm going to challenge you, and I want you guys to do the best you can. You have an assessment for this chapter. It's all you have left to do this week, unless you need to get caught up on some other assignments, but this is all you have left to do from now until Saturday, and then we'll pick up next week. I may drop assignment number 6, or project number 6, information for you by Thursday or Friday this week, but that won't be due for at least a week after I give you the initial instructions, so don't worry about that. Haven't decided what that's going to be yet, not for sure. So anyways, you have a test, an assessment, whatever you want to call it, and it's over the muscular system. I have 5 questions. If you haven't seen them yet, they uploaded, I think, last night or this morning. And basically, I have 1 question, and the first question is describe how a muscle fiber contracts from the time that a nerve impulse is generated in the brain or central nervous system until the fiber actually shortens. So you have to take me along the neural pathway. You have to talk to me about how that nerve impulse gets there, depolarization, polarization of the membrane. So again, you have to look either in your notes or you have to look online to find that information. And then once you get to the muscle fiber, as is pretty well detailed in this chapter and in other places, what happens once that nerve impulse passes through the membrane, the sarcolemma, the T-tubules of the muscle fiber? What's happening on the inside that allows it to contract? If you want to look something up quickly to get an answer, at least once you get to that point, remember you still have to get me to the muscle fiber, to the neuromuscular junction. Once you get to that point, you can look up sliding filament theory, which is something I would have covered in class with you in a great amount of detail, and take a peek at that. There are a lot of demonstrations, there are a lot of illustrations, animations online that describe the sliding filament theory and what happens chemically. I want to know the chemistry that's changing inside of the muscle fiber, and that sounds kind of crazy, but remember we talked about that. You are just a chemistry experiment, well synchronized chemistry experiment. So what's happening? That's question number 1. Questions 2, 3, 4, and 5, I give you a hypothetical disease. I call it disease A, disease B, whatever I call it. They are actually real diseases. They're diseases that I typically would cover in class with you. Some of them are in the notes, some of them are not. So you're going to have to do some searching. You're going to have to use your resources, which obviously include your computer and the internet. And I give you signs and symptoms. So first thing you have to do is identify what disease it is. So you do the best you can with that one. You're going to get some multiple responses when you put in the signs and symptoms, but if they don't apply to the muscular system directly, then you'll know that they're not probably the correct one. Once you figure out what it is, then I want you to talk to me about the pathophysiological mechanism. What is it doing? And I actually wrote this down in your instructions. What's it doing to mess you up? How does it mess up your physiology? What's going on physiologically in your body if you have this disorder or this disease? And, again, it's one thing to identify the disease. Okay, patient has this disease. What's it doing to their body? How's it influencing muscle function? Is it affecting, the contractile properties of the muscle? Is it influencing the chemistry of the muscle fiber or the muscle tissue? So that is the explanation that I'm going to need you to give me. And it's really no different than when I ask you about disruption of homeostasis on your project slides. So when you're looking at that, it's kind of the same thing. I don't want you to just tell me about systems. Obviously, we know it's the muscular system that's being disrupted. But I want you to explain to me at a little deeper level exactly what's happening. And again, it doesn't have to be super long. It doesn't have to be a paper for each answer. There's 4 different diseases that I gave you for questions 2, 3, 4, and 5. But make sure that you're able to give me a decent explanation as to what is going on, what's occurring. Hint, hint, this little thing that I have sitting in front of you here refers directly to, let me see here, question number 3. This is a mitochondrion. All right, so understand that mitochondria influence muscle function, and that's, again, understanding the pathophysiological mechanism. Have a good day. If you have any questions, ask me. Just send me an email, and I'll do the best I can to answer them. This is not an easy assessment, but it shouldn't take you too long either once you kind of get the hang of it. There's only 5 questions, but the goal is not to make this easy and just plug and chug and answer questions. I want you to think a little bit. Have a good day.